Okay, everybody, this lesson is on the quadratic formula. We have so far two ways to solve a quadratic equation. We can solve the quadratic equation by factoring, if it factors, and we also learned that we could solve a quadratic equation by completing the square. The third way is the quadratic formula, and here's where it comes from. If I take a quadratic equation like this, I can solve it by completing the square on it. And I would move the c, first of all, to the other side. Then I divide everything by a, because in order to complete the square, I need a 1x squared in the front. So I rewrite it as x squared plus b over a times x equals negative c over a. Now I have to figure out what I have to add to both sides to complete the square. To get the number that we need to add to complete the square, if you recall from our previous lesson, I take half of this. Now half of b over a is just b over 2a. You multiply it by 1/2 and that's what you get. We then square that result. So if I take b over 2a and I square it, I end up with b squared over 4a squared, and that is the number that I have to add to both sides of the equation, which I just did right there. Okay, so I've added that to both sides. The left side does factor to a perfect square. The left side becomes x plus b over 2a quantity squared. The right side, I need to get a common denominator to add these fractions together. And to do that, all I have to do is multiply this fraction right here by, needs an extra 4, it needs a 4a over 4a. I then get x plus b over 2a quantity squared, and the right side becomes one fraction, b squared minus 4ac over 4a squared. And right here I have completed the square. Once the square is complete like this, we can solve the equation by taking the square root of both sides. So that's what I'm going to do next. Square root of this side, square root of this side, don't forget the plus or minus sign there. The left side simplifies, the square root and the square cancel away and leaves you with just x plus b over 2a. The right side, the numerator is plus or minus square root b squared minus 4ac. You can't simplify that. However, I do know what the square root of 4a squared is, and that is just a 2a. Just a couple more steps here. The next is to subtract b over 2a from both sides. I'm going to put it in the front like that. Negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. We already have a common denominator, so I could put this all together and get negative b plus or minus the square root of b squared minus 4ac, and the entire numerator here is divided by 2a. And this is what is known as the quadratic formula, and that's where it comes from. So to summarize, what we have so far is this. The solutions to our quadratic equation, ax squared plus bx plus c equals 0, are here. Solved for x. This is the part that's actually called the quadratic formula right there. Let's do some examples of using the quadratic formula. Solve. Let's take 4x squared minus 11x equals 3. Now, in order to use the quadratic formula, we have to have our quadratic equation in standard form, meaning it has to be equal to 0. So my first step here would actually be to move the 3 to the left side like that. In this form, I can tell it a equals 4 here, b is negative 11, and c is negative 3. Those are the numbers I'm going to plug into the quadratic formula. I always write down the quadratic formula with parentheses first. Then I plug the numbers in. Just makes it less chance of making an error this way. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c. Divide everything by 2a. Plug in my numbers. B is negative 11, which goes there and there. A is 4, that goes there and there. And C is negative 3, which is there. Okay, everything's plugged in. Now it's just a matter of simplifying. Positive 11 plus or minus the square root of, let's see here, that's a 121. And then negative 4 times negative 3 is a positive 48. So if I add that together, that's 169. 169 over 8. Let me rewrite that up here. Okay, we have it simplified down to this. The square root of 169 happens to be exactly 13. So we have now this. I am supposed to get two answers, usually. So it's best at this point to split it into two parts, one using the plus sign and one using the minus sign. If I use the plus sign, I get 11 plus 13 over 8. If I use the minus sign, I get 11 minus 13 over 8. Simplify each one. 11 plus 13 is 24 over 8, so that simplifies to 3. That's one answer. The next one here, 11 minus 13 is negative 2. Divide that by 8, and that reduces to negative 1/4. And so we have our two solutions. The solutions to our quadratic equation here are negative 1/4 and positive 3. And there they are. Let's try another one that's similar to this. Let's look next at x squared minus 10x equals negative 25. Okay, once again, I need to move everything to the left side, so I'll do that. There we go. For this quadratic equation, a equals 1, b is negative 10, and c is 25. Okay, so those are the numbers I'm going to plug into the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c. Divide everything by 2a. And now we're going to plug our numbers in. B is negative 10, a is 1, and c is 25 right there. Okay, now we simplify. Positive 10 plus or minus the square root of, let's see, we have under the square root sign here, we got 100, and then this is minus 100. So 100 minus 100 is 0. We have a 0 under the square root sign here. Now the square root of 0 is just 0, so we have 10 plus or minus 0 over 2. Now whether you add 0 or you subtract 0 doesn't really matter. You're going to get the same result. So this is actually one of those quadratic equations that has only one answer. It is 10 over 2, or in other words, x equals 5. This quadratic equation has one solution, and it's 5. You could tell that this one would have one solution if we had solved it by factoring instead. If I take my quadratic equation there set equal to 0, this one factors to x minus 5, x minus 5. And so you get 5 twice as an answer. X equals 5 is our solution. Okay, so we could have solved this one by factoring. Keep in mind, however, that not all quadratics factor, such as our next example here. Let's look at this one now. colors here. 4r squared equals 8r minus 1. Okay. Once again, as our first step, we're going to move everything over so that the equation is equal to 0, like that. A is 4, B is negative 8, and C equals 1. Now, instead of x here, I have r, so it's going to be r equals negative b plus or minus the square root of b squared minus 4 times a times c. Divide everything by 2a. And now we plug our numbers in, as we've done before. B is negative 8, a is 4, and c equals 1. Okay, everything's plugged into the formula. Let's simplify now. We've got r equals positive 8 plus or minus the square root of, let's see what we have under the square root sign here, 64 minus 16. 64 minus 16 is 48. Square root of 48, all over 8. Let's rewrite it at the top here. 8 plus or minus, oh wait a second, the square root of 48 does simplify a bit. I could write 48. 48 is 16 times 3, and so the square root of 16 is 4. That becomes, square root of 48 is 4 square root 3 over 8. There we go. Okay. Now, some students make this mistake. Let me write it on the side here. Some students will take something like this and think that they can cross the 8s out to simplify that, and that's no, we can't do that. Here's how we simplify this a bit further. I factor out 4 out of the numerator. I can factor a 4 out of the numerator. And if I do that, I end up with 2 plus or minus square root 3 over 8. Okay, so I factored a 4 out of the numerator. Once that's factored, I can then reduce here 4 over 8. And that'll reduce to a 1 over 2. And so I end up with r equals 2 plus or minus square root 3 over 2. And those are my two solutions to my quadratic equation. If I write them separately, one is 2 minus the square root 3 all over 2, and the other one is 2 plus the square root of 3 all over 2. And they're my two what we call irrational solutions, because they have a square root left in them. Let's try another one like this. Let's look at this one now. X squared plus, let's solve here, x squared plus x over 3 equals 1 over 6. Now, nobody wants to plug in fractions into a quadratic formula, so I'm going to eliminate the fractions first. I'm going to multiply both sides by 6, the common denominator. Now, if I do that, I end up with 6x squared, distributing here, 6x squared. 6 times x over 3 is a 2x, and then on the right side I end up with 1. Move the 1 over, and we have 6x squared plus 2x minus 1 equals 0. Okay, so I'd much rather plug those numbers into the quadratic formula than what we had before. And that's what I'm going to do. So a is 6, b is 2, and c equals negative 1. Here's our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. Divide everything by 2a. Plug our numbers in. B is 2, which goes there and there. A is 6, and C is negative 1. Okay. So we end up with a negative 2 in the front, plus or minus the square root of 4, and then we got a negative 4 times a 6 times a negative 1. That's actually a positive 24. Add that up, and you have 28 over 12. Okay, square root of 28. Can we simplify that? Yes, we can. 28 is 4 times 7, and the square root of 4 is 2. So this will become negative 2 plus or minus 2 square root 7 all over 12. Okay, now at this stage, remember how we simplified the previous example. I have to factor something out of the numerator. Factor. I can factor a 2 out of the numerator, and I end up with 2 times negative 1 plus or minus square root 7, and all of that is divided by 12. I can then simplify right there and end up with x equals negative 1 plus or minus square root 7, and all of that is over 6. And those are my two solutions. If I write them out separately, I have negative 1 minus square root 7 over 6, and the other one is negative 1 plus square root 7 over 6. My two solutions right there. A little side note here. See if squeeze it on the side. Note. I could also simplify this way. When I'm at this stage, instead of factoring a 2 out of the numerator, which tends to be the easiest way, I could actually split this into two fractions. Put the 12 under each part, like that. So I split it into two fractions, putting the denominator under each part, and then reduce each part separately. And so I'd get x equals negative 1/6 here, and then right here that will be reduced to square root 7 over 6. And that is actually, oh, let me fix that. And this is actually the same as this here. It's just where we have written it as one under one fraction, one common denominator. Okay, so actually either one of these is acceptable. Either this is a solution or this is as a solution. They are both acceptable answers. Okay, let's try another one. Solve. T squared plus 4t equals, no, plus 11 equals 0. Okay. Everything is, we're in standard form here. The equation is set equal to 0. A equals 1, B equals 4, and C equals 11. I'm going to plug everything into the quadratic formula. And instead of an x here, we have a t, so it's going to be t equals negative b plus or minus the square root of b squared minus 4 times a times c. Divide everything by 2a. B is 4, goes there and there. A is 1, and C is 11. T equals negative 4 plus or minus the square root of something over 2. Let's see what we have under the square root sign. 16, and that's minus 44. And what is 16 minus 44? Let's see here. 16 minus 44 is negative 28. Is that right? Yes, negative 28. Square root of negative 28, that is an imaginary number. So I'm going to simplify it this way. I've got t equals negative 4 plus or minus, that's I square root positive 28. Okay, if we remember our imaginary numbers. And the square root of 28 I can simplify. I've done this earlier. That's a 2 square root 7. And so this radical up here simplifies to 2i square root 7 all over 2. Like that. Now I'm going to simplify just a little further here. I'm going to factor out. What can I factor out of the numerator? I can factor a 2 out of the numerator and end up with 2 times negative 2 plus or minus I square root 7 over 2. Okay, 2 has been factored out. These 2's will reduce, and I am left here with my two solutions, negative 2 plus or minus I square root 7. If I write them out separately, I have negative 2 minus I square root 7 and negative 2 plus I square root 7. And here's an example of a quadratic equation which has complex solutions, right? Or imaginary solutions. Let's look at one more, I believe, where we come up with complex or imaginary solutions as our to our quadratic equation. One more. 9q plus 3 times q minus 1 equals negative 8. Now this one obviously isn't in standard form, and that the left side is factored doesn't do any good. I'm going to have to FOIL everything out as my first step. So I end up with 9q squared minus 9q plus 3q, and then minus 3 times negative 1 minus 3 equals negative 8. Combine all your like terms, move everything to the left side, and we have 9q squared minus 6q, and that would be plus 5 equals 0. Okay, so I now have it in standard form. And in this form, I can see that A is 9, B is negative 6, and C equals 5. Okay, so those are the numbers that I'm going to plug into the quadratic formula. Here I go, Q instead of X here. Q equals negative B plus or minus the square root of B squared minus 4 times A times C. Divide everything by 2A. B is negative 6, so that goes there and there. And A is 9. And we have C equals 5. Okay. So we end up with Q equals positive 6 plus or minus the square root of something over 18. Let's figure out what's under the square root sign. That's a 36, and that's minus, what is that? That's minus 180. And so that's actually going to be a negative 144 under the square root sign. That is an imaginary number. The square root of negative 144 is exactly 12i. And so I end up with 6 plus or minus 12i over 18. Okay, so it's our imaginary number 12i right there. Now to simplify this, I'm going to factor the GCF out of the numerator, and I can factor a 6 out of the numerator here. 6 times 1 plus 2i, plus or minus that is, all over 18. The 6 over 18 will reduce and will give me 1 plus or minus 2i over 3. And those are my solutions. If I write them out separately, 1 minus 2i over 3, 1 plus 2i over 3 are my two solutions. There they are. If I choose, I could write those in what's called A plus BI form, in complex number form, and this would also be acceptable as our answers. This right here, if I split it up, I can put the 3 under the 1 and the 2i. I could write that as 1 over 3 minus 2 over 3i. And that's the same as that. And this one could be written as 1/3 plus 2/3 i. So you could either write the solutions this way or this way. Both are acceptable answers. Okay, and that's how we use the quadratic formula to solve quadratic equations. One more topic in this lesson here. the discriminant. The discriminant is the expression underneath the radical sign in the quadratic formula. It's b squared minus 4ac. The discriminant tells you how many solutions and what type of solutions you have. If the discriminant b squared minus 4ac, if you plug in your numbers, and it turns out to be positive and a perfect square, then that means that we're going to have, if we solve our quadratic formula, solve using our quadratic formula, we're going to have two rational solutions. Two rational solutions. If the discriminant b squared minus 4ac is positive and not a perfect square, then this tells us that we're going to have two irrational solutions. If the determinant turns out to be 0 exactly, then we will have one rational solution. And there's one other possibility. If the discriminant is less than 0, then that means we're going to have two imaginary or complex imaginary solutions. Okay, those are all the possibilities. Let's do a couple examples of how we would use the discriminant here. For example, find the discriminant. Six x squared minus x minus 15 equals 0. Okay. So a is 6, b is negative 1, and c is negative 15. The discriminant is b squared minus 4ac. So I'm just going to plug those numbers in. And if I do that, I end up with negative 15 squared minus 4 times 6 times negative 1. And that turns out to be, oh, wait a second. I goofed up here. B is not negative 15. B is, oh, back up. Sorry about that. B is negative 1. That goes there. And C is negative 15. That goes right here. There. Now I have it right. Sorry about that. And so this becomes a positive 1. And that's going to be a plus 360? 360. The discriminant is 361. Now 361 happens to be positive, of course, and it is actually a perfect square. It's actually 19 squared. And so it's positive, it's a perfect square, and so what the discriminant here tells us is that we will have, if we were to solve this equation, we will have two rational solutions. Two rational solutions. It doesn't tell us what the solutions are. I'd have to actually go and completely solve the equation. It just tells us the type and how many solutions we will have. Here's one more example of using the discriminant. 4x squared plus x plus 1 equals 0. If I plug my numbers in to calculate the discriminant, B is 1, A is 4, and C is 1. Working out the discriminant, we get 1 minus 16, which is negative 15. Now, since the discriminant here is negative, that means we will have two imaginary solutions. Now once again, the discriminant doesn't tell us what the solutions are. It only tells us how many solutions we'll have, 2 of them, and what type, imaginary. And that's how we use the discriminant, and that is the end of this lesson.